Hello, and welcome to Advanced Mathematics 1, Unit 8, Part 5, Solving Applications with Quadratic Equations. So there's going to be a few different types of applications we're going to look at. It's not every kind of application that there is, though. Okay, by the end of this lesson, you'll be able to solve various application problems involving quadratic equations. There's a diagram down here of one of them, which involves throwing an object and dropping an object. Our main concepts for the day are the formulas for the thrown or dropped objects. So the height in feet, h, of a dropped, thrown, or launched object based on the time, t, the object is in motion in seconds, can be modeled by the following quadratic equations. So I don't need you to memorize these, but you do need to know what the letters mean. H is the height of a dropped object is h equals negative 16t squared plus h0. We'll explain what h0 is in a second. A thrown or launched object, the height is h equals 16t squared plus v0t plus h0. So this is where h0 is the initial height in feet, and v0 is the initial velocity in feet per second. It's very important that you pay attention to the units. They need to be in feet, in seconds, or this doesn't work. So very important. Okay, this is our first example. It says you drop a seashell into the ocean from a height of 40 feet. So how long is the seashell in the air? So we're going from the point where it's 40 feet to the point where it's no feet above the surface, basically, into the ocean. So we're going to write our formula for a dropped object, which is h, that's the ending height, is equal to negative 16 t squared plus h0, which is the starting point. So we have the ending point is 40. The ending point would be 0. And then we have this negative 16t squared in the middle. So now we're ready to solve this. So first we're going to take out a common factor between 16 and 40 is 4. 4. No, it can be more than 4. Hold on a second. Okay, actually 8 can go in all that, so let's divide by 8. I'm okay, I had a brain fart there. So 0 equals negative 16 divided by 8 is negative 2. And 40 divided by 8 is 5. And now the best way to do this at this point would be the square root method. So I'm going to subtract the 5 from the other side. So I get negative 5 equals negative 2 c squared. Divide by both sides by negative 2. And we get c squared equals 5 halves. I turned it around. Hope that's okay. So that means that that's a t, not a c. I'm okay. I don't know why I turned that t into a c. All right, so t is equal to, this is going to not be plus or minus because we're looking for a positive time, not a negative time. So I can just take the square root of 5 over 2. And we actually want to figure that out for an application problem. So we take 5 over 2, and then we take the square root of that. So the square root of 2.5 is 1.58 something, 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 something. Generally, we want to go one more decimal place than what's in the problem. So we're going to say about 1.6 seconds. And that's going to be our final answer. All right. All right, in example 2, we have a marching drum major tosses a baton in the air from a height of 6 feet above the ground at an initial velocity of 32 feet per second. He catches the baton when it's 4 feet above the ground. How long is the baton in the air? We're going to start by writing the equation for a thrown object. So that's h, that's the final height, equals negative 16 t squared plus v0 times t plus h0. So now we're going to fill in the information we know. So the final height is where he catches it, which is at 4 feet. The v0 is the initial velocity, which is 32 feet per second. So 32 is v0. And then our initial height is 6 feet above the ground. So again, all of these things are divisible by 4. Well, no, 6 is not. They're divisible by 2, sorry. So we'll divide everything by 2 to start, just to make this a little easier for ourselves. 32 divided by 2. Sorry, I had a brain fart. 16. And then 6 divided by 2 is 3. Best way to do these is to move everything to the same side of the equation. So I'm going to kick the 2 to the other side, so it's not going to affect the t squared or the t at all. When I subtract 2 from 3, I get 1. Now you can solve this any method you would like. I just use the quadratic formula. It's just generally going to be your best bet for problems like this, is to use the quadratic formula. So I have my a is going to be negative 8. My b is going to be 16. And my c is going to be 1. So I have my t equal to the negative b, which is negative 16, plus or minus square root b squared, 16 squared, I don't know off the top of my head. So that's 256, sorry. Gonna erase that little line that I started to do. 256 minus 4 times a, whoops, I don't write the a, I write the number, okay. I'm not awake yet this morning, obviously, so 8 is negative 8, and c is 1, all over 2 times negative 8. So I'm going to move up here. I have negative 16 plus or minus square root of 256 minus 4 times negative 8 times 1 is 288. All over 2 times negative 8 is negative 16. Again, you can just figure out both of these. So we have negative 16. Let's go ahead and do square root of 258 first, actually. So square root of 258 is like 16.06. So I have negative 16 plus 16.06 all over negative 16. That's plus or minus, actually. We gotta try both. So negative 16 plus 1606 divided by 16 is a negative number. It's negative 2, basically. And then the positive, then the other one is negative 16 minus 16.06 divided by negative 16 is, again, it's positive, it's 2. So it's 2 seconds. And that's the final answer. Okay, in our last couple problems, we are going to be dealing with geometry. It's best to draw yourself a picture. So I start with a scarf that is 60 long by 4 wide, and then I'm going to increase the length and the width. It says the increase in the length is 3 times the increase in the width. So if I call the increase x, then the increase in the width is x. So now my new width is 4 plus x. And my new length, I'm increasing by 3 times x, which would be 60 plus 3x. And it tells me that I increase the dimensions of the scarf to 396 square inches. So that's the area of the scarf. So area is length times width. So I have 4 plus x times 60 plus 3x is equal to 396. So I'm going to need to start by multiplying this out. So 4 times 60 is 240. 4 times 3x is 12x. 60 times x is 60x. And x times 3x is 3x squared. So I'm going to go ahead and kick that 396 to the other side. And then rearrange my terms. So I have 3x squared plus 12 and 60 makes 72x. 240 minus 396 is negative 156. And then I get 0. All of those numbers are divisible by 3, so I'm going to go ahead and divide out a 3. That's a 3. X squared, then, plus 72 divided by 3 is 24. And 156 divided by 3 is negative 52 because it's negative. And I'm just going to solve this by factoring because it's able to be factored. Usually these ones with geometry can be. So I'm going to go ahead and look for multiples of 52 that subtract to 24. Those happen to be 26 and 2. The 26 will be positive, and the 2 will be negative. So if we set both factors equal to 0, we get x is negative 26, which is obviously not correct. You can't increase something by a negative length, and you get x equals 2. So the dimensions in the new scarf would be 60 plus 3x and 4 plus x. So I put in a 2 in place of the x, and I get 60 plus 6 is 66 inches by 4 plus 2, which is 6 inches. And if you multiply that together, you should get 396 if you did everything correctly. Yeah. All right, in our final example, we're forming a right triangle to use as a base. So I'm going to draw myself a right triangle. It tells me that the hypotenuse must be 10 feet longer than one leg and 5 feet longer than the other. So I need to relate these both to the hypotenuse. So I'm going to call my hypotenuse x. So if it's 10 feet longer than one side, then the side is 10 feet less than it. And if it's 5 feet longer than the other side, it's 5 feet less than it. And obviously I have my hypotenuse is x. So now I need to use the Pythagorean theorem that says leg squared plus leg squared equals hypotenuse squared. So we'll simplify that out. These are both perfect squares. So I'm just going to use the formula. So it's going to be twice the middle term, this is x squared, and then the end term squared, and twice this term. And then twice that squared is 25. And then over here we have x squared minus 10 is minus 20. 10 squared is 100. So I'm going to subtract an x squared from both sides. And you can see one of them drops out. I'm left with x squared. Negative 10 minus 20x is negative 30x. 25 and 100 add to 125. So I'm looking for things that multiply to 125, that subtract to 30. That is 25 and 5. So the 25 needs to be negative, and the 5 needs to be positive. So I have x minus 25 equals 0, and x plus 5 equals 0. That gives me x is negative 5, which is not possible. Can't have a negative hypotenuse. This gives me x is 25. So my hypotenuse is 25. So let's find my other ones. So x minus 5 would be 20. These are all in feet. 25 minus 10 would be 15. And then my hypotenuse is 25 feet. So those are the three measurements of the sides of the triangle. And that's all there is for today. And I will see you next time. Goodbye.